Hello everyone. In our previous video lectures, we have learned about that to achieve greater concurrency, we need to go for a non-serial schedule. But a non-serial schedule can suffer from inconsistency. So the better approach will be if we can prove that a non-serial schedule is serializable, then we can say that this non-serial schedule can achieve more concurrency as well as the result will be consistent. There are two types of serializability, view serializability and the conflict serializability. We have learned that each and every conflict serializable schedule is actually a view serializable schedule. To prove a view serializable schedule is basically an anti-conflict problem, and as the number of schedule increases, it is very difficult, almost impossible, to prove that a schedule is a view serializable schedule. So the better approach will be if we can prove that a schedule is a conflict serial schedule. So, what do we understand by a conflict serial schedule? Before going to that, we need to understand the idea of the conflict equivalence. Two schedules S and S bar are said to be conflict equivalent if the order of any two conflicting operations is same in both of the schedules. If a schedule S can be transformed into the schedule S bar by the series of swapping of non-conflicting operations, then they are equivalent. We have learned that there are two things we need to consider. One is the conflicting operation and another one is the non-conflicting operation. Two operations of a same schedule are conflicting operations if they are from different transactions, they work on the same data or access the same data, and one of them is a write operation. All of the three conditions need to be satisfied for being a conflict operation. So, using some example, uh, we are going to explain the conflict operation. In this example, we are using the schedule 1, and this notation we have learned that the first operation is the read operation by the transaction 2 on the data item B. And the second operation is a read operation by the transaction 1 on the data item B. Now, these two operations are definitely non-conflicting operation because none of them are writing operation. Now, to identify a conflicting operation, the process will be we start with the first operation, then go through the schedule and find any of the write operation by a different transaction on the same data. So you can see that here there is a write operation by transaction 1 on the same data B. So my conflicting operation will be R2D and W1B. This one and this one. Now there are no more conflicting operation depending on this one. Now next conflicting operation, for finding the next conflicting operation, we need to consider the second operation, that is the reading of data B by the transaction 1. So the conflicting operation can be writing of data B by the transaction 2. So these and these are two conflicting operations. So R1B and W2B are two conflicting operations. Next, there are no more conflicting operations for this operation. The next one is, remember, we need not to consider the conflict, the operation which we have already done. Now, for this operation, it is a write operation and it is done by the transaction 2 on the data item B. So, this one be the conflicting operation for this operation. So, the next conflicting operation is W2B and W1B. And no more conflicting operation regarding this. For reading of data A by the transaction 1, the conflicting operation is the writing of data A by transaction 2. So R1A and W2A are the conflicting operation. Next, W1B will, there are no conflicting operation after that. So we can go for the next operation. So R2A and W1A is the pair where there is a conflict on the data item A and one of the operation is a write operation and both of the transactions are not same. So these are the conflicting operation for my schedule 1. Next, let us take another example. We are going to consider the schedule 2. So the first operation is a read operation on data item B. So its conflicting operation can be a writing on data item B by any other transaction. Let us find that is there any operation on that like that or not. So there is a conflicting operation. So R1B and W2B are the conflicting operations. Then there is no more conflicting operation. Next, R2B will conflict with any write operation on data item B by any other transaction. So this one and this one are the conflicting operations. So R2B and W1B are the conflicting operations. Then R1A will conflict with W2A. There is another conflicting operation on this one. So there is another conflicting on operation on data item B, which is the writing of data item B by transaction 2, which will conflict with the writing of data item B by the transaction 1. We need to consider this operation. So this will conflict with this operation. So R2A will conflict with W1A. And finally, this operation will conflict with this operation. So W1A will conflict with W2A. So these are the list of conflict operations for the schedule 2. Now, if we consider the concept of conflict equivalent, we can say that by swapping of non-conflicting operations, we can prove that one schedule can be transformed to another schedule. So here the non-conflicting operation is obviously this one and this one. Similarly, this one with this one with this one with this one. So these are the non-conflicting operations. How can we prove that two schedules are conflict equivalent? Now, if I want to prove the schedule 1 is conflict equivalent to schedule 2, then we are going to swap the non-conflicting operation of schedule 1 to make it similar to the schedule 2. So these two are the non-conflicting operations, so we can swap them. After swapping, the transaction will look like now these two are non-conflicting operations, so we can swap them. So it can be written as these two are non-conflicting operations, so we can swap them and we can write. Now if we consider the schedule 1 by exchanging the non-conflicting operations, we can see that it is similar to the schedule 2. We can say that the schedule 1 is a conflict equivalent schedule to schedule 2. Next, by using the idea of conflict equivalent, we are going to define the conflict serializability. So what is the conflict serializability? When a schedule is conflict equivalent to a serial schedule, we say that it is a conflict serializable schedule. So consider the schedule 3 and there are two transactions T1 and T2, and the following schedule can be either schedule 6 or schedule 7 using the same transaction with same operations. So let us exchange the non-conflicting operation. These two we can write this. Then these two are non-conflicting operation, so we can swap them. So we can write next These two will be non-conflicting operation. So we can write, and finally these and these are non-conflicting operation. So by swap we can swap them, and finally we can write. So we can see that the schedule 3 is equivalent to schedule 7, which is a serial schedule. So we can say that the schedule 3 is a conflict serializable schedule, and its corresponding conflict serializable schedule will be schedule 7. So the corresponding serializable schedule is T2, and after that it will be followed by the transaction 1. So it will produce the same consistent result as the serial schedule 7. So let's practice one more example with conflict serializability. In this series of video, in the part 3, we have proved that the schedule 1 and schedule 3 produce the same consistent result. And in that video, we have mentioned that the schedule 3 produce the same result because it is a serializable schedule. Now, why it is a serializable schedule? So, by removing all the buffer operation and keeping only the read and write operation, the schedule 3 will look like this one. So, to prove that it is a conflict serializable schedule, what we can do up to now, we can only swap the non-conflicting operation. So, first identify the non-conflicting operation. This one and this one are non-conflicting operation because they are performed on the different data. So these two can be swapped. Those two can be swapped. So after swapping, the schedule will look like this. Now you can see that this operation and this operation is non-conflicting because they are performed on different data. So we can swap them. Now the reading of B and reading of A can be swapped because they are non-conflicting. Reading is not a conflicting operation. So after swapping, and finally the reading of data item A and writing of data item B is not conflicting. We can swap them. So finally the schedule 2 will look like this. So we can see that the transaction 1 is performed entirely, then the transaction 2, which is a serial schedule. So the operation will be transaction 1 followed by transaction 2. So that is why the schedule 3 is producing a consistent result similar to the serial schedule given in the schedule 1. It may be easier to generate a serializable schedule when by swapping the non-conflicting operation when there is less number of transactions. But as the transaction number increases, it is much more difficult to do that. Now, is there any algorithm to perform to check a non-serial schedule is conflict serializable or not? There is an algorithm, and the algorithm uses the precedence graph. What is a precedence graph? It is basically a directed graph represented by G, which is a set of N and E, where the N are the nodes represent each and every transaction. So in a schedule, if there are n numbers of transactions, then in the graph there will be n numbers of nodes. Now E is the directed edges, and there will be a edge from one transaction to another transaction if there is a conflicting operation. So in other words, we can say that there will be a edge from transaction I to the transaction J, that is node I to node J, if node I, if transaction I write a data item before Tj reads that data item. Second, there will be a node if the transaction I reads a data item before Tj writes the same data item. Finally, if Ti writes a data item A before Tj writes the same data item. So you can see that these three are basically considering the conflicting operations. Now, when we have generated the precedence graph, then we are going to look for a cycle in that graph. If there is no cycle in that graph, then or the graph is acyclic, then we can say that the schedule is a conflict serializable schedule. And if there is a cycle, then the schedule is not a conflict serializable schedule, but it may be a view serializable schedule. Let us take an example. So we are going to consider the schedule 8, and we have already proved that it is a conflict serializable schedule. So schedule 8 you can relate to the schedule 3. It is similar as schedule 3, and you can see that there are two transactions. One is T1, another is T2. So there in the precedence graph there will be two nodes T1 and T2. Now we are going to design the directed or going to put the directed edges. So you can see that T1 is reading our data before T1 T2 is writing the data item A. So there will be a edge from T1 to T2 on the data item A. Mentioning the data item is not necessary, and for similarly for this operation and this operation there will be a edge from T1 to T2, and this operation with this operation there will be a edge from T1 to T2, which is already done. Now T1 is reading a data, later T2 is writing that data. So there will be another edge from T1 to T2 only, but here the data item is V. Now for this data operation, this operation and this operation, there will be a edge from T1 to T2. So you can clearly see that there is no edge from T2 to T1. So the graph is not a cyclic one. So we can say that the schedule 8, which is similar to schedule 3, is conflict serializable schedule. Now from this graph also, we can conclude that the corresponding serial schedule will be T1 followed by T2, transaction 1 followed by transaction 2. That's it for today's video. In the next video, we are going to solve some more precedence graph with more number of transactions involving in the schedule. Thank you.